Good morning, 7th grade. It is Thursday, April 23rd, and it's normally test day, but we're not quite ready for a test, so we'll have one next week. And we're going to go ahead with lesson 105. So on lesson 105, we're going to talk about the surface area of right solids and spheres. So on this first side of our board, we're going to talk about three types of prisms. The first one we're going to talk about is a triangular prism. And so here what I have is a triangular prism. We know it's that because we have a triangular base here. And I went ahead and put dashed lines that represent the interior edges of, well, the edges of the triangular prism that you can't see normally. So I made them dashed. And that really helps you see all the faces. And there are 5 faces. There's the front triangle, the back triangle. We have a rectangle there that slides down. And then we have a rectangle at that it's sitting on, and then this back rectangle here. So since we have 5 faces, we're finding the surface area. That means the area of all the surfaces or the faces, as if we were painting the outside of the prism. So I'm going to write here that we have 5 faces, and all we're going to do is find the area of the 5 faces and add them together. So let's start with the area of the triangle. It's 4 times 3 is 12, divided by 2 is 6. And so I have a 6. I have another area of 6 because I have a back triangle. Now I have this triangle that's really kind of like a slide, almost sloping down here in the front. And it is a 5 by 6. You see it right there? 5 by 6. Now, 5 times 6 is 30. So that front rectangle has an area of 30. And then let's talk about the one at the bottom. It's a 3 by 6. Well, 3 by 6 is 18. And then I'm going to look at this back one. Now, I put the 6 up here because this length of 6 matches this length of 6 right here. So I can see that this back rectangle is a 6 by 4 or a 24 for an area of the back rectangle. So now I have 5 faces, the area of 5 faces. Let's just add those together and we'll get the total surface area for this triangular prism. So I've got 12 up here with 6 and 6. 8 and 4 is 12. 12 and 12 is 24. And 3, 4, 5, 6, 7, 8, 84. Let's say that this is, it's inches. And so it's area, so it's going to be square inches. 84 square inches, the area of the 5 faces added together. Now let's look at a rectangular prism, alrighty? All of the sides here, or the faces, are rectangles. So how many faces does a rectangular prism have? Well, it has 6, whereas a triangular prism only has 5. So let's go ahead, and I'm going to put 6 faces here. And we're going to find the area of the 6 faces and add them together for the surface area, just the area of the surface itself. Now, let's take this front rectangle, and it is a 5 by 3. I put the height here and the height here so we can use it to do several rectangle areas, but 5 times 3 is 15. Let's write that down. The front face has a matching back face, and so it will have the same area, 15. Let's go to the face over here on the left. It's a 3 by 4, a 12 for its area, and then it has a matching one on the right side that is also 3 by 4. It's a 12, and then what's left is the very bottom and top rectangles, and both of those have an area of 4 times 5, or 20. So I've got a 20 and a 20. Well, I'm running out of room at the bottom here, aren't I? Okay, so let's see what I have. I have 5 plus 5 is 10, 11, 12, 13, 14. I'm going to squeeze a 4 down there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 94. Whoops. So I've got a 94, and my units are in centimeters, centimeters squared for the total surface area of the triangular prism. Now let's go to the cube. Now we actually had one of these for homework last night, but let's go ahead. The surface area of a cube is really the easiest one because every face is a square and they're all the same area, and there's 6 faces, So I can just multiply the area of one face times 6. Well, the area of one face, this is 3, this would also be 3, is 9. So this square has an area of 9, and there's 6 faces that have an area of 9, and 6 times 9 is 54. Let's call that one inches squared also. So that's how we find the surface area of triangular, rectangular prisms and cubes. Now, there really is no special formula for these. Just figure out how many faces you have, find the area of each face, and add them all together. Okay, now we're going to go to a couple more of our three-dimensional figures or solids that do have special formulas. All right, the first one we're going to talk about is a cylinder. Now, let's talk about a cylinder real quickly. I'm going to take a soup can. Here's a soup can, okay? And it's Progresso soup, chicken and wild rice. Now, if I want to find the surface area, I'm going to figure out what are all the surfaces that I have to calculate the area for. Well, I've got this top circle. Okay, I got to find the area of that. The top lid, the bottom lid is another circle. And then I've got this side label. I've got to find the area of that. Okay, now before we do that, let's go ahead and I'm going to draw this little figure here. I have to have the area of the two circles, right? And those are pi r squared. I have to have a pi r squared area and a pi r squared, plus I've got to have the area of the soup label. Now, I'm going to go ahead and take the soup label off here, and let's see what we have. Let me put the can down, and we have what shape? We have a rectangle. So let me go ahead and put a rectangle here, and when you see this, when you're thinking about the surface area of a cylinder, think about this face. Okay, I got 2 eyes, a nose, and a mouth. Okay, now, what are the dimensions of this rectangle? Well, this dimension right here, we call that the width, is actually the height of the can. So let's put that over here. Here's the height of the can, is this dimension. Now, what is this dimension? Okay, what is this dimension? Length times width. What do we call this width, this length? We know that this width here is actually the height of the can. Well, let me put my pen down a second. Let's think about what happens when we put this back around the can and figure out what this length is. Well, what does it wrap around? It wraps around the circumference of the circle on the lid. So, actually, the dimension across here is, let's pull it like this, when I curl it up, okay, this long length here is actually the circumference of the lid's circle. It's the circumference of the circle. So when I open it up, it looks like we see all of that, and that is the circumference of the circle. My fingers are inside. The circumference of the circle. Okay. Now, the circumference of a circle, we decided is this measurement. Circumference is pi d. How do I find the area of any rectangle? Well, it's length times width, and the length is the circumference because it wraps around the circle of the lid circle, and then the height is the width, okay? So length times height. So pi d times h, okay? Pi times the diameter of the circle times the height of the can. Now, let's take this diagram and write our formula for the surface area of a cylinder. Well, if I have 2 circles, 2 pi r squared, if I want to add pi r squared and pi r squared, I have 2 pi r squareds, 2 areas of my circle, okay, that gives me those 2 areas. Then to find the area, and by the way, the area around the side is called the lateral surface area, okay? A lateral pass in football is to the side and kind of back, but lateral means side. So this is called the lateral surface area, and remember, it's the soup label, and so it is, I'm going to add that part of it, it is pi d h. Now, let's quickly use this cylinder to find its surface area. Well, I'm going to leave pi as 3.14. I'm going to start with 2 because there's 2 circles, a top and a bottom, and the radius is 1, and 1 squared is 1. So here's the area of my 2 circles. Now let's find the area of the soup ladle, okay? Or the lateral surface area. It's going to be pi times the diameter, which would be 2, and the height is also 2. So let's go ahead and multiply this out. Well, 2 times pi is 6.28, and pi times 4 is, I'll tell you, is 12.56. And so then all I have to do is add those together. 12.56 plus 6.28, 5881. I get 18.84, and let's call that inches squared. This is area, okay? So 2 pi r squareds plus pi d, wraps around the circle, times the height. Okay, now let's talk about a sphere. Now I know this looks like a circle. Please don't judge. I don't know how to draw a sphere. Some of y'all can probably do it with some beautiful shading. But imagine this is a sphere, okay, with a radius of 2. For a sphere's surface area, the area around the sphere, okay, let's think of an orange, okay? I want to find the surface area of the orange. Well, what I could do is slice that orange right down the middle and hold up that half an orange, and I would have the biggest circle I could make in a cross section of that orange. So I take the area of that circle, pi r squared, and I multiply it by 4. So 4 times pi times the radius of the sphere squared will give me its surface area. So that's really a very nice, neat, cool formula. So the surface area of this sphere with a radius of 2 would be 4 times pi, and my radius squared would be 2 times 2 is 4. So it would be 16 times pi. Now to save us time, I'm not going to multiply that out because we're going to do one on the homework here right now, okay? But here's your formula, 4 pi r squared and for your sphere, and here is your formula for the surface area of a cylinder. 2 circle areas plus circumference of the circle times the height of the cylinder. Okay, now let's go to number 17. We're going to do 3 homework problems together. Number 17, get out your homework sheet and let's get working together. We have a ball and we want to find its surface area, not its volume. We'll do that later. Its surface area, the outside surface area of the sphere. So we know that surface area of every sphere is 4 pi r squared. So let's take a 4. We're going to use 3.14, I think. Let me check real quickly. Number 17, let's look real quickly. I think the units are in inches, and we're using pi. Okay, we're using pi. All right, so we've got 4 times pi, and what is my radius? My radius is half the diameter. It is 10, and 10 squared is 100. Okay, now let's be smart about this. 100 times pi would make 314. So let's take 314 and multiply it by 4. You go ahead and do it on your paper and I'll do it and we'll compare our answers. I'm getting 1,256 and my units are inches squared. So I first multiply my decimal number pi times 100, made it a whole number 314 by 4. Here's the surface area in square inches of that ball. Okay, let's go to number 21, a cube. These are my favorite. Okay, in 21A, excuse me, we're finding the volume. And the volume of any cube is going to be the side length cubed. And in this case, my 5 is cubed. And you know what 5 cubed is, don't you? 5 times 5 is 25 times 5. I get 125. Let me check the units. The units are in millimeters. So my volume would be millimeters cubed. Millimeters cubed for the volume of my cube. Okay, let's go to the surface area. We recall from the other side when we did it, there are 6 faces here. Each face is a square with the same area, And the area of each of these is going to be 5 times 5, which is 25. Well, 6 times 25, well, what is that? 6 times 4 is, 25 times 4 is 100. So 2 more, I'm getting 150. Now this is surface area, millimeters squared. Okay. Now the last one we're going to look at is number 23. And this is the surface area of a cylinder. This is the big one. Okay. Now, 22 says to do the volume. And remember, volume is area base times height. And my base area is going to be the area of my circle times its height. So I'm not going to do that one with you, but that's just a little precursor. You can go back and do that one in just a minute. But let's do the surface area of the cylinder. Let's go ahead and write the formula first. Well, we have 2 circles to find the area of, so that's 2 pi r squareds, plus we're going to get the area of the label, right? The soup can label, the lateral surface area. What is the area around the side here? All the way around, and that is the circumference of the circle times the height of the can. In this case, it's just a plain cylinder. So let's fill this in. I believe I'm also supposed to use 3.14 here. And my R is 10. I love that number. R squared is 100. Let's go ahead. That's the area of the 2 circles. Let's find the lateral surface area. It's going to be pi. The diameter is 20. I'm running out of room. The height is 10. Squished it there on the end. Can you see it? Hold on. There we go. There it is. Sorry, it's so squished, guys. Now, let's keep going. Well, let's again multiply pi times 100. That would give me 314. And how easy is it to multiply 314 times 2? 628. Now to that, those are the area of my 2 circles. I'm going to add my lateral surface area, the soup label, okay, the side area. This is pi times 20 times 10. Well, 20 times 10 is 200. What is 2 times 100? 200. And we know 200 times pi is 628. So over here, 200 times pi, this number is also 628. That is very rare for your area of your 2 circles and your lateral surface area to be the same number. It just happened to work that way with these dimensions. Don't get too used to that, okay? Now, the final answer is going to be to add these together. And so I'm just going to take 628 and multiply it by 2. And I'm getting 1,256. My units are in centimeters, and this is area, so centimeters squared. Centimeters squared. 2 pi r squared plus pi dh. Aren't you glad you don't have to memorize that, because everything is open book with distance learning? Okay, now you probably already noted up here, I've got the omissions written up here, so let's go over those. They are 6 and 10, 15, 16, and 20, and 24, and 27. One more time. 6, 10, 15, 16, 20, 24, and 27. We've also done 17, 21, and 23 for homework on the board here. So, a lot. Surface area, okay? So you've got to know the 2 formulas for the cylinder surface area and the sphere. The other prisms, you just find out the number of faces and add all the individual face areas together. Okay, so this is due on Monday because Friday is your catch-up day, okay? So this is Thursday and it will not be due. I will not be taking grade till Monday. And you know what would be the most exciting thing ever for me? If I could get everybody to put their homework on the assignment page. And if you have trouble with that, you can email me. But if I could get everybody's homework, I would love that. It would be such a treat, such a treat. So do that homework, put your answers in, my math assistant, and right away, take that picture and upload it. And you're done, okay? So I don't have to try to plead and beg for you guys to give me your stuff. All right, well, have a blessed day and have a blessed weekend and enjoy your Friday. And I'll probably be in touch with you if you don't have everything turned in But check Gradebook, because I'm putting a note there with what I'm missing from you, and so we can all get caught up. All right. Well, I will see you at Zoom today, or I will talk to you again on Monday. Have a great long weekend. Bye-bye.